The definition of oxidation and reduction. Oxidation is the gain of oxygen and reduction is the loss of oxygen. But there is another way of defining those terms. Oxidation is loss of electrons and reduction is gain of electrons. This time, gain and loss are the other way round. Instead of oxygen, we are talking about electron exchange. Electrons are negative, meaning that gaining electrons makes an element more negative. In other words, it is reduced. If you find this difficult to remember, the mnemonic oil rig might help. Oxidation is loss, reduction is gain. Why is this definition useful? Well, not all oxidation-reduction reactions involve oxygen. Take HgCl2 and Li for example. Lithium metal, the more reactive of the two metals, is more keen to be part of the compound. It is therefore oxidized from lithium metal to lithium plus. This is known as a redox reaction. Let's take a closer look at what happens to the two metals. Lithium gives up one electron to form lithium plus. This means the lithium is oxidized. At the same time, mercury, Hg, collects two electrons to make mercury metal. In other words, mercury is reduced. Its charge, or oxidation state, is lowered. These are known as half equations. Only one ion is shown and seemingly free electrons appear. Half equations are an easy way of looking at what happens to one component at a time. Joining two half equations together and balancing charge eliminates the electrons. This balanced equation needs two lithium species for every mercury. Let's revisit the hemoglobin example we used in the last video. When the iron 2+ in hemoglobin takes up oxygen, it is reversibly oxidized to iron 3+. The half equation for iron is very simple. Iron 2+ is in equilibrium with iron 3+ and one electron. Iron is oxidized in the forwards reaction. Can you write the half equation for oxygen forming the superoxide? Pause the video for a moment and think. The answer is that oxygen remains bound to oxygen, but undergoes reduction, gaining an electron from iron. Transition metals, like iron, have variable oxidation states. The number of electrons they can lose is determined by where they sit along the periodic table. Metals with high oxidation states often want to have lower oxidation states and be less highly charged. This means they are very reactive, positively charged species. Oxidants. When a highly charged metal, like chromium 6+, reacts with a less highly charged metal, let's say manganese 2+, it takes electrons. Chromium is reduced and manganese is oxidized. If we look at this from the perspective of chromium, chromium is doing the oxidizing, making it an oxidant. In the same way, manganese reduces chromium to chromium 3+, which is a stable oxidation state. Can you balance this equation? Pause the video whilst you work it out. Ready for the answer? OK. This reaction can also be written as two half equations. Write down the half equations for chromium and manganese. Which species is the reductant? Pause the video again whilst you work it out. Ready? Chromium is the oxidant, so manganese is the reductant. In a real reaction, chromium and manganese ions are parts of compounds like sodium dichromate and manganese chloride. This can often make it more difficult to see what is being oxidized and what is being reduced.